title I personally like is How to Be an Open Source Ass. So that's the one I'm going to give today, because I'm feeling a little saucy. So, as I said, I work for Citrix. I came from Cloud.com acquisition. I'm an open source guy. I pretty much like the open source aspects of software development. The technology that I'm working on now is very cool, and I'm fortunate. But this talk is going to focus on open source specifically. That doesn't mean that I have any, there aren't good proprietary solutions out there. There are. It's just boxing it into an open source ecosystem where you can go and participate and use the software, help co-develop it is where I'm going to focus. Yeah.
I know that Citrix is a big company.
Right.
So what does it do?
What does it do?
Yes.
I'll get to that in a little bit.
Yeah, okay.
To what our products do in open source.
Yeah.
Yeah, I'll touch on that in a little bit. Cool. So we're at OpenCloudConf, and I hate to always do the definition slides, but if I don't do the definition slides, people are on a different page. So I'm going to go real quick on what I'm talking about when I say cloud. These are the obligatory what is a cloud slides with on-demand self-service, broad network access, resource pooling. So your old proprietary, your old software pre-cloud was buckets. Now we have one great big bucket. Elasticity, it grows and shrinks on demand. Measured service. If it doesn't have these 5 characteristics, some marketing guy at an ASP, a software company or a SaaS company has told you they're cloudy, and if it's not there, they're not in the cloud. 3 models for service delivery. The one we're not going to talk much about from an open source standpoint today is SaaS, which I call the user cloud. These are things like Gmail, Twitter, things that are usually Salesforce.com. All those things are user specific. The 2 areas I am going to talk a lot about today are the development cloud, which is PaaS, platform as a service. I think that's one of the coolest spaces out there. I think that's sort of the cutting edge of where the cloud is today. And then the systems cloud, and that's infrastructure as a service. And that's the stuff I do at Citrix, and it provides the foundation for all these other cool things. It's taking your old networking, storage, compute, and pulling it and making it elastic and easily consumable. Right? Here's the end of the definitions. Public, private, hybrid. Public, somebody else is hosting it for you in their data center. Amazon EC2, Rackspace, Terramark, people like that. Private cloud, it's running on your hardware in your data center. Software I'm going to talk about today is CloudStack, OpenStack, Eucalyptus. Greg was the guy talking the last talk. Then hybrid cloud. Hybrid cloud is distributing loads between the 2. There's some cool stuff there. For the majority of people, I don't think they do hybrid cloud. I think they're usually doing one or the other, or they have both, but they're not actually migrating workloads across. There are some cool tools out there like Grayscale that helps you do that kind of thing. But for my talk, I'm going to talk about mainly how you build the private cloud with open source software. Even though open source does power a lot of the public cloud, like Amazon, it's built on on the Zen hypervisor and a lot of other open source bits. Here's the theme for today is that I think people are pretty willy-nilly about the way they deploy clouds, partially because it's so easy. I can get my credit card out, go to Amazon, spin up a couple cloud instances really, really quick, and I have cloud infrastructure. But I don't think people think about what that looks like. They don't have design points that are very good in a lot of cases. Because we're early on, I think a lot of people use it as skunkworks. I think a lot of people are doing it very, very cool stuff like Netflix and others who are actually doing scalable architecture in the cloud. That's what I want to talk about a little bit today. The other thing I want you to come away with is that whatever you do in the cloud, I want you to make that replicable. So if you don't have a plan to build your infrastructure in your cloud environment, whether it's Amazon, whether it's OpenStack, whether it's vCloud, whatever, I think you're going to have failure, especially at scale. Okay, so those are the definitions. That's the easy part. What we're really going to talk about today is how we build those kind of clouds with open source software. And here's a generic architecture diagram. So you have your physical resources, your servers, your storage, your networking. You have some operating system and some VM manager that rides on top of that. You have virtualized resources. So you've taken your servers and you've virtualized them. You've taken your network and you've virtualized them. You take your storage, you've virtualized it. That's the underpinnings to deliver the three service models, the SaaS, the PaaS, IaaS. That's the heart of the cloud. That's only half of the equation. If you don't have the tools to manage this scalable, ephemeral, elastic infrastructure, I think you're going to fail. So we're going to talk about how we build the cloud, but then we're going to talk about how you're going to manage it, some of the tools there. So why open source is the question. And the answer is, at least for me, is I think open source has a lot of advantages because it's usually user-driven. That means, I work for Citrix. We sell proprietary software. We sell $2 billion of it a year. We're pretty good at it. But we also know that there's a lot of cases where if you don't have that user input to inform what you're delivering, it's really difficult to anticipate the problems. And as in a new, unestablished industry like cloud computing, we want to have these feedback loops. Things are moving really, really fast. All the talks of the last couple days, I bet you every bit of software out there has gone through multiple release cycles in a year, versus back in the early 2000s, twice a year was an aggressive release cycle for a lot of software. Things move really, really fast. You get people that can help you test, they can give you input, and help the software evolve. It's a lower barrier to participation. It's free as in beer is the open source moniker. You can download it, use it, and redistribute it for free. The barrier, and that's a cost of participation. Your time is also valuable as well, so that's a lot of time what you're trading. The other thing that's interesting is in the open source communities, you have a lot of people that have the same kind of problems as you, and they're helping each other. And that's what I think is really cool, because the people who are doing cloud at scale are participating, or you're doing cloud, I shouldn't say at scale, are participating in these communities and sharing their experience. In a proprietary model, the only people that can participate are people who pay the software fees to participate in the user community there. As I said earlier, they have aggressive release cycles, and they typically adhere to open data, open standards, and open APIs. So when we talk about open, let's go to the IaaS layer, the virtualized servers. There aren't a lot of standards in cloud computing, but there is one that is an established ISO standard, and that's an open virtualization format. And it's a standard for packaging virtual machines. So the virtual machines that are running in your cloud, along with some metadata that are held in the directory, that is what the open virtualization format is. It's different than if you had a VMDK for a VMware. It's actually got additional data in there. The other thing is it has a disk image in there. That disk image has to be compatible with the hypervisor you're using. So, for example, if you're using something on VMware or Xen, you have to have an image format that's VMware or Xen can consume. But the idea behind OpenVF is that if you have a package, you can move that across from one provider to another, providing that can accommodate the dependencies. And so Amazon has their AMI format. KVM is a virtualization software. They have QCOW2 format. VMware has a VMDK format, etc.
So this is different from VMware?
This is a disk image format. This is a way to package appliances. So like VMware has VMDK,
So
or VDM.
It's different.
Yes, it's different. A VMware image could be a subset of an OVF.
Okay.
Does that make sense?
Okay.
So the OVF has some metadata that says has attributes of that image, so that you can pass it across. So typically, what you would do is you could import an OVF into your virtualization layer, and run it from one provider to another. So there's the way that you might have done, created your virtual images in the past would be mount an ISO inside of your VM, inside of your virtualization layer, and install your software directly. There's a bunch of tools out there that I think are interesting that allow you to provide some set of specifications and then dynamically create open source images. So this is basically these tools to create Linux images. Windows, since it's not open source, is not going to fall in these categories. Bitnami, I think they're one of the sponsors. They provide a service that allows you to download, generate pre-developed images for open source frameworks like Drupal, Joomla, WordPress, etc. And then they have an update service to keep them up to date. Boxgrinder, this is the one I think is the most communities in the cloud right now. As I said, they started in 2010, and they've been very aggressive with development and release. They just released their latest release last month, I believe, called Essex. They named their releases after cities in Texas, so A, B, C, D, E. It's their fifth release of OpenStack since July 2010. So that's pretty aggressive release cycles. They are Apache licensed. They support all the hypervisors in that list, quite a few. They have a lot of partners who are doing integrations with OpenStack. And they just recently announced their foundation with support from major players like IBM and Dell and Red Hat.
So this is an overly provocative question, but one of the things that's fairly obvious is that if you look at the open source projects in general, Apache projects very often have multiple commercial suppliers, right? Hadoop's a great example for Apache product coming out from the Cloudera and Hortonworks and so forth. OpenStack, Apache, multiple Nebula, Vista, and so on and so forth, and HP. CloudStack, Apache. Do you anticipate, would this be a good endorsement for CloudStack if there were an additional commercial distributor of CloudStack above and beyond Citrix?
Sure. I think the key, and this is what's, I really like Apache, but I think there's some dangers to Apache. And the danger is because you don't have to share your changes, you can fragment. So I would say that if we get multiple vendors that really allow you to move from a Piston Apache cloud to a cloud scaling Apache cloud to a Nebula Apache cloud, that is good. And the same thing for CloudStack or any of these products. If it gets to the point where the vendors fragment and there's not compatibility from one powered by OpenStack cloud or powered by CloudStack cloud someday, and that's bad for the user. I mean, that's the danger of having a permissive license is I think your users and the market will dictate that you can't do that, but I think that there can be some strife because there is no, the thing that made Linux successful is that it was minor, which is Linux's GPL license, minor forking, but everybody had to share their changes and it's always maintained as a large group with multi-vendor ecosystem compatibility that I can run on Canonical's Ubuntu or Red Hat Enterprise Linux or CentOS or any of these flavors. So that's the, I think it's good, but it's only good if it's good for the customer and avoids fragmentation and lock-in. So, and so far, I don't know that it's too early to see if that's going to be the case in OpenStack or not. But
I mean, the reason I think it's important, and I apologize for taking too much of your time on this, but cloud computing solutions are very large, complex, multifaceted, multi-component systems, right? And so you would expect over time specialized distributions to emerge in specialized networking or different kinds of support for different kinds of hypervisors, whatever it might be, support for different kinds of CPUs. So you would expect things that kind of divergence to emerge. Much harder if it's all controlled by a single vendor, as Eucalyptus, I think, will be going forward.
Right.
A question about GPL. So if we use that as a hosting, we don't need to release the code, but do we need to pay for the GPL?
So the code is free. You can buy You can buy commercial software and support for GPL software, but all these are free.
Even we use that for hosting.
Use it for hosting, use it to host gaming site, use it for, you know, running a business, it doesn't matter.
Okay.
Yeah. So. I'm going to touch on this just very briefly because the terminologies, when we say scaling, there's two kinds of scaling. And so we have these virtual machines and they're running inside of our cloud. So there's scale up and there's scale out. What we mean by scale up is that the resource footprint for those virtual machines increases. But you can't increase that dynamically to a virtual machine that's running. What happens is that you start and stop your virtual machine with a larger service offering typically. When I first heard about cloud computing, I had the idea that you would upload your application into the cloud, and if you needed resources, they would just automatically come to you. So if you needed more CPU, and I'm what I'm talking about specifically is CPU and memory, it's automatically going to be allocated to you and it would run forever. That's not the case. Your vertical scaling, when we talk about that, we're talking about your virtual machine footprint. You can expand that footprint, but not in a live machine. The thing that really can take advantage, the things that applications that are taking advantage of cloud scale are ones where you have an application that can add additional virtual machines and consume those resources as workers. So think about a web scale application where you have a front-end load balancer and additional, as you bring up additional machines, they would handle the load of serving web pages or something like that. Scale out. So there's a lot of cool, in the open source world, there's a lot of cool tools out there that do it. They're a little rough. One of them that's cool I like is called Scalar, S-C-A-L-R. In the software as a service world, there's another one I like. It's not open source, but it's very cool. It's called RateScale. Those kind of tools help you with those kind of problems. So, scale up, scale out. So we talked about the vert layer, and how we create a IaaS compute layer. So that's, if you're using the Amazon terminology, that'd be like your Amazon EC2 layer. Now, if you want to talk about your storage layer and some of the tools out there to help you do scale distributed storage, I'm going to talk about GlusterFS. GlusterFS is a scale-out NAS system that can aggregate storage over Ethernet and InfiniBand. It was developed by a company called Gluster, who has recently been acquired by Red Hat. GlusterFS project is an open source project. It's very cool and interesting. Another one, and I always capitalize it, I don't know why, it's not an acronym, is Ceph. I go back to my initial thing of why I like open source, is one of the things that is cool about open source, it's often developed by users. Ceph was originally developed by DreamHost, which is a hosting company out of Los Angeles, and it's a distributed file storage system, very similar to Gluster. Then you have Swift, which is an OpenStack project. So on OpenStack, technically the compute layer is called Nova, and there's a lot of other sub-projects in OpenStack that support Nova. On the storage side, you have OpenStack Swift, which is the original code for something called Rackspace Files, which is their storage cloud offering from Rackspace, very similar to Amazon S3. They made all that code available and they developed it now under the OpenStack. If you're a KVM user, there is a interesting storage project called Sheepdog, and Sheepdog does storage specifically for KVM virtualization. And Sheepdog's developed, again, by user. NTT is one of the lead developers for Sheepdog. It's Sheepdog had some, I don't know if they've overcome it, but I think they had sort of around a 1,000 host limit for storage, which could be plenty. But when it comes to how you store stuff in the cloud, especially on the compute layer, you have sort of your what I call primary storage. This is the storage where your hypervisors, where your disk images are running for that your hypervisors are using. And then you have longer term storage. So you might have snapshots of your virtual machines as they run. So something like Swift is ideal for storing them, or templates. So when you spin up a virtual machine, you might have a template that is your image that generates that virtual machine. You might store them in something like Swift. GlusterFS and Ceph might reside over commodity storage and help for all sorts of performance and redundancy. One of the interesting things about Gluster is that it's a headless storage system, so all the nodes are aware of each other. So if one of the nodes, there is no master-slave relationship. It's all distributed.
A question?
Sure.
Why not include HDFS in there?
So you
It's
could.
missing something.
So I typically don't, but you could make that list very, very long. But HDFS is a Hadoop file system, which is pretty specific to doing MapReduce operations through something like Hadoop or.
Well, one, to me, an interesting question about storage systems like that is whether you can store small files or large files. And obviously, HDFS can only do large files, right? And so, are any of these suitable for small files? I thought somebody mentioned to me Ceph was actually useful.
Ceph works great.
Yeah.
Ceph is full projects. The question is, the problem with HDFS is that until they fix it, there's still a single point of failure in the
That's
which means that it's not particularly useful for very large scale services like this. These are all in GlusterFS, Ceph, and certainly Swift, all designed for very high availability scale out usage.
So you could have an HDFS cluster that could be working outside of your base cloud for specific apps like MapReduce.
Yeah.
You might be using XFS or something for small file saves, depending on your use case. But I'm talking about just sort of your core generic compute platform. So that's a good point. I didn't talk about Hadoop, but just since it was brought up, Hadoop is what they call MapReduce. So, as what it can do is take large data processing jobs and parallelize them, and allow it to do calculations, then recombine them for some result very effectively. It's often associated with the cloud, but it's really awesome data crunching, parallelization stuff that could be running on bare metal as well. So earlier today there was a talk about APIs, which is a hot topic in the news these days because Google and Oracle are in this litigation because Google used some subset of a Java API, and Oracle's contention is that API is copyrightable and they're not allowed to use it. Google's like it's an API and it can be used. I'm not a lawyer, so I won't go into that. But the thing that you might want to consider watching is someday could our APIs be subject to licensing under some terms, which is what Google's and Oracle case will probably help us decide. But anyhow, all these clouds have an API. So they have an application programming interface that people can interact with to create and destroy images. They can do all sorts of different things. You can deal directly with a single cloud API. So the sort of de facto standard today is the Amazon API, simply because Amazon is the biggest cloud provider, and a lot of the ones like Eucalyptus I mentioned tries to keep fidelity between their API and Amazon to the extent they can. We do the same with CloudStack. I believe OpenStack has some kind of Amazon API compatibility layer. And the idea is that if you're instrumenting against these APIs, that you don't want to have to relearn an API if you move across clouds. The thing that's cool is we have people like projects like JClouds, LibCloud, Delta Cloud, Fog, who are out there creating these cloud control. Adrian calls them cloud controllers, and basically they are an API that can actually make API translation calls to all these cloud providers. So JCloud supports like 30 providers. Delta Cloud provides a translation layer to all these other APIs, so that if you are interacting with your cloud, like they all probably have some way to do it simply, but you're probably making RESTful calls to a cloud API to accomplish tasks. What you can do is you can make those calls to any of these four up here, and then they'll translate the calls so that if you move from Amazon to Rackspace or CloudStack to OpenStack or Eucalyptus to wherever, that you would have your tooling instrumented to a single API, and then they would broker those calls across different clouds. If you're thinking about multiple clouds or you're not sure where you're going to go, I personally think that this is a really good way to go. So we talked about the infrastructure as a service, which I call the systems cloud. The developers cloud is the PaaS, platform as a service. What this is it's abstracting out the infrastructure and giving you a containerized place to develop your apps that handles some of the things like auto-scaling. It's theoretically, they should be containerized so that you can move your apps across from different cloud providers, etc. It's pretty new, and that's why I say theoretically, because practice versus the vision. I'm sure that's how it will be in the long term. Short term, there isn't a ton of PaaS cloud providers out there to prove that. So the ones that are most notable, Cloud Foundry was started in VMware last year. They just celebrated their first birthday. They have a lot of, it's really cool. You can actually, if you're a developer, develop your Cloud Foundry app on your laptop. It's containerized and you can move it into a hosted image really, really easily. OpenShift was originally a product developed by a company called Wakara. I believe yesterday they officially announced the open sourcing of OpenShift called OpenShift Origins. It does auto-scaling, it provides some containerization. It's very, very interesting. I'm not a developer, so I have to take everybody else's word for it. PHP Fog is another one, developed by AppFog. Staccato is another. It's actually a derivative of Cloud Foundry with some interesting bits and additional domain languages that are supported in it. I have WSO2 Stratus on there, which is sort of PaaS-y, but they're more like a continuous application development system that sort of predates PaaS, and they're trying to move into that space. They have a lot of people that use it at scale and do some interesting things, but I struggle with whether that should be on there or not, but I mention it because in the Java community they have some good traction and some really interesting full application cycle management tools. So that's
do they all auto-scale?
I don't know about Cloud Foundry by default. Does it?
Yeah.
Okay. OpenShift definitely does. AppFog on their hosted service does. And I believe PHP Fog, the project, does as well. Staccato does as well. WSO2, that's why I'm sort of on the fence on there, because it's more deployment, but I don't think they have the auto-scaling intelligence in there. I'm not 100% sure. I have a whole list of a lot of these things, and trying to keep up with the features is really difficult. So that's why I have the links in there, because you know, I gave this talk on Saturday, and OpenShift Origins didn't exist, and now Open Source Origins exists. But
is that all? That's all for the platform?
Those are the ones that are open source that are worth
What
mentioning.
about the Google App Engine?
That's not an open source, it's a
It's not open
service.
source.
It's a service, but the code for Google App Engine is not available. You couldn't run Google App Engine on your hardware, but you can go to Google App Engine and run your application there. So it's a service, but it's not software that you can download and use. Okay? Yeah?
If you're saying that which one's your auto scale, by that we mean what? In terms of servicing requests from the web, or interfacing that between storage and those requests?
So
obviously you can really break anything.
theoretically, you would be limited if you didn't have an IaaS layer that could handle the scale that your PaaS layer was consuming. You would either be finite. The idea is that your IaaS layer is infinite to serve your PaaS layer, and if you were deploying it, you would have that provisioned appropriately. Because, you know, if you're going to a service provider, you would expect it to be infinite. If you're doing it on premise, you would have to provision it just like you would any other app. application.
What I mean is your application itself might actually, if it's like no shared data, right, between your compute elements, obviously you can scale as much as you want, but if you have shared data, then that's not going to infinitely scale either, no matter what you do, right?
If I didn't catch the.
If your data is all shared, it's not going to scale.
If your data is shared, but if your data is probably not saved in the past, it's probably saved. It's probably available as data as a service.
Yes,
right?
I'm just wondering which assumption are you making? Here?
So I would make the assumption that you have a Java app, and that Java app threads. And as that Java app threads, it would consume resources that would, within the domain language environment, that it would consume. And perhaps it has data that it uses, but that data would be served as a service, just like your other things. So I'm talking specifically about the app that runs within it.
Right.
And perhaps if you're a service provider, you're probably offering multiple services that are all amalgamated into a solution. But yes, but for what I'm talking about here is the developer's cloud, specifically that app that's written for PHP or Python or Java that's consuming those specific resources. All right. So we are pretty close to the 45 minutes, but I don't know that we have anyone after us, so I'll slow down. I won't go so fast. So I have the ability now to easily spin up virtual machines. When I used to, I don't do system administration work anymore because they probably wouldn't let me in the data center, but in the old days, you'd call up Dell and you'd say, hey, I need a server, and you didn't go to the web because you couldn't order on the web back in those days. And they would send you a server and you would rack it, and there was a limiting factor. Now I can take my credit card, I can go to Amazon, and the time I gave this talk, you could have spun up, 1,000 servers. But if you don't have a plan to manage that, you're sort of out of luck. So in my day, I was part of the meat cloud. I was the guy racking and stacking servers. Cloud operations today, to scale at the same level as the creation of infrastructure, you've got to automate. So you need your cloud robots to go out there and do that. Now I'm going to talk about a lot of the open source tools. There are other tools out there that are really, really good at that. So I don't want to limit you to that. If you just want open source, that's what I'm going to talk about. There's other people that are like Grayscale and Service Mesh and others that offer tools like that to help you do this. Neither one's better. It's just different. Just like there's plenty of people here, I'm sure, that might look at vCloud versus the solutions I put out there, and that's perfectly acceptable as well. So the 4 types of tools I'm going to talk about are very specific to open source and very specific to Unix. So we have provisioning tools. That's the creation and patching tools. We've got config management tools. These are the ones I think are most interesting because they're not widely adopted yet.
Hey, I'm after you.
Oh, you are?
Yeah.
Okay, so I will clear it up.
But you can keep going. This is good stuff.
Okay.
Tee me up.
Okay. So we have orchestration tools. They actually are command and control tools, and then monitoring. Monitoring is the most boring stuff ever. If you saw what I did before, I used to do monitoring for a company called Xenos at open source. That's really, really hard to do well, and I think a lot of people do it poorly. What I want you to get out of the way that you create your tools is you want to do what developers do. They create tool chains where the output of one tool informs the input of another. So your monitoring tool might tell your patching and provisioning tool that it needs to update a system. And your patching and provisioning, when it's done, it might go out and tell your config management tool to set parameters for your web servers, your databases, or your IP tables. If you have put them together in such a way that they all work together, that's going to give you the automation, the robots I was talking about. The next talk we're going to hear is obviously RightScale. They do that for you. Linux space, if your Kickstart is the old way to automate the install of a single server. You give it a bunch of data of what packages you want installed, spec file, and automatically installs that and automates single server. Cobbler is a tool developed in the Red Hat incubator. It allows you to do a one-to-many, so it lets you kickstart across a bunch of servers and apply patches. There's Spacewalk is another cool project out there by Red Hat. And then in the OpenStack space, use something called Crowbar that allows you to automate, automate the bare metal provisioning of Dell servers and bring OpenStack hosts online. It's based off a configuration management tool called Chef. So Chef, Puppet, CF Engine, and this new thing called Salt are all what I call configuration management tools. Salt's sort of special case, so I'm going to come back to that one. But what these do is they allow you to create manifests that tell you how to configure your servers. You can actually define roles, and then you can apply them across many servers at once. Very, very cool stuff. Salt does that, but the way it does it is sort of through a command and control interface. So you can use Salt to do that kind of create manifests. I think they call them grains. There's a whole set of terminology that's all around Salt. It's sort of bizarre that allows you to do command and control things like set parameters in Apache web servers across multiple servers at once using 0MQ. You can also use Salt to stop and start services and do other things. Saltstack.org. I would say everybody that I know that's doing cloud at scale in the open source world is using either Chef and Puppet. They're using the Chef if they are using an open source tool. Monitoring tools, the ones that are out there that are open source that are interesting are Cacti, Graphite. They let you do time series data, so they allow you to graph performance over time. Nagios, Zabbix, Xenos, they do availability monitoring for Nagios. Zabbix does that as well, and so does Xenos. The thing I like about Zabbix and Xenos are that they let you do availability monitoring and performance monitoring in one tool. So anybody here use Nagios? Anybody here use something called Cacti or Graphite? So Nagios, one tool you have to configure to do security tests. Is it up and down? Is a service available? That's sort of cool. Cacti is out there collecting time series data through and saving it in RRD files and then giving you graphs. The two on the bottom, you add the host once and they can graph and they can do availability and they can do some alerting of if something's up and down. Orchestration. This means it goes out and does stuff on your behalf. Sometimes it can queue it, authenticates against your machines, and does rudimentary tasks. The ones that are interesting are Salt I already talked about. It can do configurations. mCollective integrates with Puppet. Funk integrates nicely with Cobbler. Rundeck is really, really cool. It's been developed at a very big gaming company that does something like Farmville, or maybe Farmville. And what it does is allows you to create jobs, execute those jobs, and set priority, and then it gets the feedback from those jobs to tell you how they've completed and any feedback they may have. Capistrano is more of a, sort of like a desktop power tool for system administrators. You can authenticate against your machines, execute certain functions. It allows you to do one-to-many operations.
How much they are tied to the databases behind them?
Pardon me?
How much they are tied to the database behind them?
Databases behind them?
Yeah.
I don't know. I would expect, I think, actually I don't know. I can't even answer it.
What's the difference between MIT and Apache license?
They're both basically permissive licenses. MIT is a little bit more liberal than Apache in their restrictions. I don't think you have to keep the copyright, if I recall correctly, intact. But I'm almost out of time, so I'll have you Google that. But basically, they're both copyleft licenses. So here's what I wanted you to take away. Your tools, the tools I talked about, if you're sitting them and putting them on top of management in the cloud, what would be, in my fantasy cloud world, if they let me back in the data center, would be the ability to dynamically generate images out of Box Grinder, have the CloudStack API, CloudStack start up those images, provision those images, or patch those images using Cobbler, configure them using Chef or Puppet, start and stop services using Rundeck, and then monitor them there using Xenos. And as things happen in your cloud, so if a server goes down, you can use your monitoring solution to alert different parts of these toolchain to actually do things. So Xenos has the idea of what they call automated remediation. So based on a condition. So say you are at X% of usage across a storage volume. You could alert one of your provisioning tool to go out there and provision another server. You could actually add that to your CloudStack cloud through their API, etc. So I sort of rushed through this, but I do have a solution for you if you're interested. I didn't put the date. So a week from Thursday in San Francisco, we're having a Build a Cloud Day. It's at the West End on Market Street, and we're going to talk about the how to build and manage a cloud, and we'll have people from all these projects, from some of these projects there. So we'll have the CloudStack people. We'll do an install of that. We'll have Canonical there talking about Ubuntu's strategy for the cloud. RightScale will be there talking about how to manage it. Xenos will be there talking about monitoring. Zen.org will be there talking. And afterwards, we'll have a few cocktails. So,
what date is that?
May 10th. So if you go to cloudstack.org, we have a listing. Also, we have a whole bunch of videos there in depth from all those projects talking about how to create these tool chains. So we have a lot of the projects I talked about recorded on cloudstack.org on the, under software and videos. So also, these slides are at slideshare.net. All my speakers notes and links to all the projects are there. So if I went real fast and you couldn't get to them, just go to slideshare.net/socializedsoftware, and I uploaded those slides today. And if you have questions for me, I am way over my time limit, so feel free to email me or my phone, or follow me on Twitter, or however you choose to. And then I put a bunch of resources in the slides, if you download them, to pages that I think would help you get this. So I'll take like 2 questions, but we
Can you go back to slides just so that we can capture that link? Yeah, thank you.
Sure. Socialized Software is the username under that. Cool. So that's it.